Hello, welcome to Samarpit Academy. In this video, we will be discussing 4 to 5 electrical instruments. Now, what are these instruments and what is the purpose of this instrument is the aim of this video. Now, let us start with one very important instrument or device. We call it as galvanometer. Now, you can see the galvanometer here. It has two terminals, positive terminal with a red screw, negative terminal with a black screw. Now, what is galvanometer? Remember, galvanometer is a device which is used to detect current in a wire. Suppose, let's say there is a conductor. I want to check whether a current is flowing in that conductor or not. So, what I will do is, I will connect this galvanometer to that conductor. If I observe any deflection in this galvanometer, I can assume that there is current in that conductor or wire. But if there is no deflection as far as the galvanometer is concerned, then I can assume that there is no current in that particular conductor. Now we can see the diagram over the left side. Basically, in this, you can see the needle is pointing at 0. As long as the needle points at 0, we can say that there is no current. But when the needle deflects towards right or towards left, we can assume that there is current flowing in that particular conductor or wire. So what is the purpose of the galvanometer? The main purpose of the galvanometer is to detect small currents in a conductor or in a wire. So in a conductor or in a wire, if small currents are flowing, then we can use this galvanometer to detect those currents. For example, you might have seen that an electrician basically uses tester to check whether the current is flowing or not. In the same way, the purpose of the galvanometer is also the same, to detect small currents which are present in a conductor. Not only that, sometimes this galvanometer can be used to measure small currents also. For example, in this diagram, you can observe that below the G symbol, it is written that 20 microampere per division. That means one division here is equal to 20 microampere. So if the needle points at 10, the current can be calculated by multiplying 10 into 20 microampere. That is 200 microampere. So there are the main purpose of the galvanometer is to detect small currents in a conductor. But sometimes this galvanometer can be used to measure small currents also. This is the main purpose of galvanometer. Now, here you can see that there is a needle, that means the needle is pointing at 0. The 0 is in the middle. Right side you can see some 30 divisions, left side you can see 30 divisions. Now the needle can deflect either way. Either it can deflect to the right or towards the left. Now what is the meaning of this, or what is the conclusion for this? Now see, a current is flowing in a conductor. Let's suppose the needle has deflected right. But after some time, I can observe that the needle has deflected towards left. Now what I can say about the change of deflection is the current direction has changed. So when the current direction changes, the direction of deflection will also change. Initially, the deflection may be some 10 divisions right. When the same amount of current is reversed, the deflection can be 10 divisions left. So galvanometer can be used to verify whether that direction of current has reversed or not. This is the second purpose of galvanometer. Now third, like if at all that means, for example, you can see in this particular diagram, below G it is written that 20 microampere per division. That means one division is 20 microampere amount of current. So if at all this is given, we can measure the current also. But if this is not given, that means one division is how many microamperes or how many amperes of current. If we don't know that, then we cannot say how much current is exactly flowing, because we don't know the value of one division. But for suppose, if there is a wire and let me put here. So let's suppose there is a wire. Some current is flowing, let's say I1. and the galvanometer has showed some 10 divisions. Now I have connected this galvanometer to another wire. Some current I2 is flowing and the galvanometer has shown 20 divisions. So if I don't know one division is exactly how many microampere or how many amperes, I cannot exactly say what are I1 and I2. But what I can say is I2 is greater than I1. That means I can compare these two currents. So in this way, galvanometer can be used to detect small currents. If at all the value of one division is given, we can measure small currents. We can say whether the direction of current has reversed or not, and we can also compare currents in some situations. So this is about galvanometer. Now when we show this using a symbol, that means in circuits, if you want to show galvanometer, so we will show galvanometer like this. We will write here G, the two terminals positive and negative. So this is all about galvanometer. Now let's jump to another device called as ammeter. So you can see the diagram here. Ammeter, A is written here. So what is ammeter? Ammeter, basically you know that current. What is the symbol for current? The symbol for current is generally I. So current is denoted by capital I. And current is measured in units called as ampere. So what is the standard unit? What is the SI unit of current? Ampere. So ammeter basically is a device which measures current. So the purpose of ammeter is to measure current. Now ammeters can be of many types. For example, you can see in this diagram, this ammeter can measure a maximum of 5 ampere current. So the range of this ampere is 0 to 5. I can have another ammeter whose range is 0 to 10 or 0 to 15 or 0 to 20. So the purpose of ammeter is very clear. It is used to measure the amount of current in a conductor or in a wire. It can be of different ranges. Now how to show ammeter in a circuit? So we can show ammeter like this. Put A here. It is also having two terminals. One is positive, other one is negative. So suppose in a wire if you want to measure current, so ammeter should be connected in series to that wire where you want to measure the current. Suppose here you want to measure some current I1, so the ammeter will read the amount of I1. So this is about ammeter, a current measuring device. Now you might have also heard about voltage, potential difference. So the potential difference between 2 points or the voltage between 2 points can be measured by a device called as voltmeter. So again, it is also having two terminals, positive and negative. Positive generally we show by plus, that is positive is generally shown by red color and negative is generally shown by black color. Now see here, suppose let's say this is a resistor and this is some point A, this is some point B. I want to measure the amount of voltage between A and B. So what I will do is I will connect voltmeter parallelly across 2 points where I want to measure the voltage. This is how voltmeter is connected. So just now I have told that ammeter is connected in series. In series to that wire where you have to measure the current. And voltmeter is connected parallelly across 2 points where you want to measure the current. So the connection for ammeter is a series connection. The connection for voltmeter is a parallel connection. Now you can see that this voltmeter can measure a maximum of 5 volt. So you can have, that means ammeters can be of different ranges. In the same way, voltmeters can be of different ranges, 0 to 5, 0 to 3, 0 to 10, 0 to 15, or 0 to some 100 milliampere, anything, millivolt, anything it might be. So ammeters, voltmeters can be of different types depending upon their ranges. So this is all about voltmeter. Now, so you might have heard about resistance. So what is resistance? When current flows in a conductor, it will face some opposition. This opposition we call it as resistance. So generally it is denoted by symbol R, and the SI unit or the unit in which this resistance is measured is ohm. Symbol is this. This is the symbol for ohm. So just now I have told you that current symbol is I. Generally current is measured in amperes. Symbol is A. Potential difference or voltage. The symbol is V. and the unit is also a volt. Volt unit, that means the unit for voltage is volt, and it is also having the symbol V. Now coming to resistance, symbol is R and the unit is ohm. So now we are having a device called as ohmmeter. So the name itself tells that this is a device which measures the resistance of a particular material. So how much resistance that particular material has can be measured by using this device. So we have till now discussed 4 devices. Let me give you a quick recap. First one is galvanometer to detect current or sometimes to measure small currents. Second is ammeter to measure exactly how much current is flowing in a wire. It is always connected in series where the current has to be measured. Next is voltmeter to measure potential difference or voltage across 2 points. It is connected parallelly across the 2 points. And next one is ohmmeter, which measures resistance. Now we have discussed 4 devices. Every device has its own purpose. Every device has, that means we can connect the device in a particular way. But we have a device called as multimeter, which can do many things. So this device which you are seeing on the screen is multimeter. So the name itself tells that it is a multi-purpose device. Now you can see an arrow here. If you place that arrow over V, you can measure voltage. If you place that arrow across A, you can measure current, ampere. If you place that arrow across ohm, you can also measure resistance. So multimeter is a multi-purpose device which can be used to measure current, voltage and even resistance of a material. So multimeters are commonly used because they can be, that means they can be used to measure more than one parameter. So if you want current, if you want voltage, if you want resistance, any of these parameters can be measured with this multimeter. And digitally, it will present whatever the value or whatever the amount of current, whatever it may be. So this is a device which we commonly use. So that is all about these electrical devices. In this video, we have just understood the basic purpose of the device and how the device is to be connected. But there are a lot more things that need to be studied, how the device is constructed or what is internal in the device, how the device is basically working. And I've told you 3 devices. For example, in the starting, I've told you 3 devices. One is galvanometer, ammeter and voltmeter. But remember, this, suppose you're having a galvanometer, by making some modifications, you can convert the galvanometer into a suitable ammeter, and you can also convert that galvanometer into a suitable voltmeter. So this we will discuss about all this in the next videos. So thank you for this.